Everybody, my name is Arnulfo, I'm from Mexico, and today I will talk about the inverse function. What is an inverse function? The inverse function is a method which we apply to find the opposite function for a term or a variance. So, to get started, what we need to do first is to check that our actual function is a one-to-one function. But, what is a one-to-one function? A one-to-one function is a kind of equation that has two different domains for only one range. But let me explain you this in a graphic way. So let's think we have this function, f of x equal x squared. This function would be sort of this way, passing through the zero origin. Now, as we can see, we can select this x, this point in x, and this point in x, and we can see that they're crossing through the same area in the range. An easy way to see if this equation is not a one-to-one is by making horizontal lines through the function, and if they are touching 2 points, like here and here, in the same range, this will not be a one-to-one function. Now, the question is, how can we make this function into a one-to-one? It is pretty simple. What we need to do is select just one side of the parabol, and now cut this function into half. Now we have that f of x equal x squared, but x would be bigger than or equal than 0, or in other words, x belongs to the real numbers, but x would be bigger or greater or equal than 0. And this is how you represent this, and selecting just this half of the parabol. Now in this, if we have a function that goes f of x equal x, we're going to know that this function would be right this way, crossing through the origin, and it would be obviously a one-to-one function, because if we make lines, we'll see that they're just crossing through one dot in the domain. So let's get started with the inverse function. Let's imagine we have this function, f of x equal 5 times x plus 3. What we first need to do is to follow the 6 steps that I will tell you as we go on. The first step is to substitute the f of x into y. So in this way we're going to make the work easier and faster. Our second step is to change places the x to the y. So in this way we're going to isolate the other variable in an easier way too, and this will be x equal 5 times y plus 3. Our third step is to isolate, as I said previously, the variable y, and this would be x minus 3, it's equal 5 times y plus 3 minus 3. So this way we're going to eliminate this 3. Now we're going to pass this 5 in a division. It will be x minus 3 over 5, it's equal to y. So this would be our inverse function, but we can make this in an easier way and make it through another equation, and this will get sort of this way, x over 5 minus 3/5, and this would be our fourth step, that we change the y into f minus 1 of x, and this represents our inverse function. So here's where we get into our fifth step. This fifth step is by asking ourselves, how do we know that this inverse function is the correct one? So it is in an easy way. What we need to do is to make a composition of each one of both our original function and the inverse function. So it would be f of g of x and the g of f of x. So let's make first the first one, and it is our original function, which is 5 times x plus 3 is equal to f of x. What we need to do is to see where is our x or variant. Here is it, and what we need to do is to substitute it with the inverse function. So it would be f of g of x is equal to 5 times our inverse function, which is x over 5 minus 3/5, and this would be plus 3. So let's solve it. This would be 5x over 5 minus 15/5 plus 3, and it would get us x minus 3 plus 3, and this would be the way I eliminate this, and this would be y if we substitute this, and y equals to x. This will tell us that our inverse function is a correct one. Let's make the second part of our fifth step, and it is by making the composition of our inverse function. It will be the g of f of x, as I said previously, and the g will represent obviously the inverse function. So what we need to do first is to write our inverse function, which is f minus 1 of x is equal to x over 5 minus 3/5. We need to see where our variable is, and we need to substitute it with our original function. So the g of f of x would be our original function, which is 5 times x plus 3 over 5 minus 3/5, and this would be x plus 3/5 minus 3/5, and we eliminate this one, and ta-da, we're having y equals to x. So our inverse function is a correct one. Now we're going to make our sixth and final step. In this way we're going to see the difference that are in both functions, and why are we calling these functions inverse. So what we need to do first is to graph our original function, and our y-intercept will be the 3, and now our x-intercept would be minus 3/5, and we're going to sketch it in a quick way. This would be something like this. Now we're going to sketch the other graph, our inverse. What we need to do to make this sketching easier, we need to take these functions, the 0, 3 and the minus 3/5, 0, and what we need to do is to make them change places and use them in the other graph. So I will teach you how. So we have that these points will be crossing in our original function. What we need to do to graph the other function is to pick these points and just change them places and use them in the other function. So it will be 0, 3, 3 and 0, minus 3/5. So as we graph it, it would be this way. The 3 would be here, and the minus 3/5 would be over here. Yeah, over here. So we sketch the graph, and it would be something like this. As we can see, we can see that our graph will have a reflection that will pass through this side, through this line, and it will be a reflection from the original to the inverse one. And this is how we sketch a graph, an inverse graph. So this was inverse functions. Hope you enjoyed the video, and don't forget the 6 steps. Goodbye.